Welcome back, everybody. We trust that all of you have enjoyed your tea break. Now, let us proceed on with our agenda for today. As global manufacturing grapples with escalating trade tensions and resurgence of protectionist policies, the additive manufacturing industry faces both unprecedented challenges and transformative opportunities. Now, the recent tariff hikes have disrupted supply chains and also increased production costs, and this is definitely prompting companies to reevaluate their sourcing strategies and explore localized manufacturing solutions. And so this brings us to our upcoming session, Additive Manufacturing, a Global Outlook. And so it brings me great joy to present our next speaker. Now, he gives strategic and business development advice to companies in additive manufacturing, and he helps with due diligence, partnerships, and application development. He has been active in additive for over 14 years and has worked with some of the largest and highest performing businesses in the 3D printing market. Please put your hands together to welcome Mr. Joris Peels, Vice President Consulting, Additive Manufacturing Research. A round of applause, please.
All right, so thank you, everyone. So if we look about 10 years ago, additive manufacturing was strategic for 3 countries. One of those countries is the United States of America. The United States of America, which has been responsible for inventing and commercializing most of the additive manufacturing technologies, used additive to stay ahead in aero engines, to create hypersonic vehicles, which is the new high ground, the new way to get anywhere and see anything and do anything before anyone else does, and to shore up their, nuclear deterrent, in fact, by 3D printing missiles, rocket engines, and ICBM warheads. The United States then expanded and went on using exquisite machines to make exquisite things. The few things that are important for the US continued dominance in the world. And these things were successful. One of the things the United States has done that I don't think any other country can until now do is take a problem, the fact that it could not by itself go to space. It did not have the engines and the capacity and the institutional capacity to go to space regularly. It did not have an alternative to the shuttle program. And it turned this into a gigantic space industry, where hundreds of billions of dollars flow to US companies, and all of these companies are using additive manufacturing for the rocket engines, because it's faster and it's cheaper. For missile production and solid rocket motors, also 3D printing is the number one technology. For drones, from the very cheap to the very exquisite, it is also the default manufacturing technology for a lot of components. So the United States tried to stay ahead. Meanwhile, China tried with less exquisite machines, with higher part volumes and lower part cost, and more players that are now being consolidated into national champions, tried to also get ahead and use it as a lever to counter the United States and to surpass it. But it did it with a much more broad-based technological approach that led to lower part costs, but a laser-like focus on anti-ship missiles, radar, RF, and components where China could really keep the United States at bay. There was another country that also 10 years ago saw additive manufacturing strategic, and that is Singapore. And we've heard about what Singapore did, and it tried to shore up its resilience, shore up its ability to not have to choose between these 2 players, and its ability to respond in a world that is now, very sadly, seeming to not conform to what we believe is globalization. We are in a world that is more fraught with difficulty and more unpredictable than before. Certain things that we thought would never happen have happened, and alliances have separated and values have drifted apart. Now, there's another country that now also considers additive manufacturing to be strategic, and that is Ukraine. Ukraine will make 5 million drones this year at least. On these drones, the propellers always, and certain other components are 3D printed. But Ukraine's 3D printing innovation goes much further. The drones cost around 180 euros in price. They are iterated every few days. The technological innovation and advance of technology in Ukraine is faster than anything I've ever seen. It is light speed technological innovation. It is faster than any industry, any business, anywhere. And Ukraine is going much further. They're not only using this for drones, they're using it to make shells, to make munitions, to make lots of other components that are being broken. And what we're also seeing is that an individual warfighter in Ukraine can order a part or sketch a part on the back of a napkin, and that part will get made by a non-profit or a kind of semi-government funded organization. So the individual warfighter can get something delivered exactly how he or she wants it. So these are very, very different approaches. We see in Ukraine the rise of the Chinese desktop 3D printer to a reliable manufacturing device, making tens of millions of parts, end-use parts in things like missiles, in things like consumer electronics, in things like machine tools. We also see the exquisite machinery of the United States and the exquisite approach of a very kind of high-tech, exquisite manufacturing to further hypersonics, done by both China and the United States. And we see very different approaches to try to broadly increase a country's resilience. The hybrid approach favored by Singapore, the more exquisite approach favored by the United States, the wider technological lower part cost approach by China, and now the desktop, we innovate as fast as we can because we have to keep the country alive approach of Ukraine. So what can we learn from this as a country? What can we learn from this as manufacturers, right? Which of these approaches do we take? And can we manufacture? And what can we manufacture? So for example, what end-use parts can we make? And what end-use parts can we not make? Can we do things like make the tooling for an injection mold line so we change the injection mold line to a new part quickly? Can we make sand cores? Can we make intermediates? And through which machines can we do that? These are the things we're going to be talking about with our panel. I'm very happy with the panel. I'm very happy that we get these people together to talk about the overall state of the world and how additive can make organizations more resilient. Now, part of it, of course, I'm not going to give, if somebody gives me a brush, I'm not going to turn into Van Gogh or something. I'm not going to magically be able to paint. So a printer can't make you more resilient. But a printer coupled with training and the right will and the right organization can maybe increase your resilience. And we're going to be talking about how this can be done for individual organizations and countries with our panel today. And I'd like to thank you for the time you've given me today. And I'm really looking forward to the discussion we're going to have just now. Thank you.
Thank you very much, Joris. So we will now proceed with our first panel discussion. To join us on stage, let's welcome Dr. Terry Wallace, Distinguished Fellow of Advanced Manufacturing, Wallace Associate, powered by ASTM International, Mr. Matthias Schmidtler, Managing Partner, AM Power, Dr. Jean Ong, Director of Ecosystem and Internationalization, NAMIC, Dr. Ehsan Toysakani, Director, Multi-Skill Additive Manufacturing Lab, and Ms. Kitty Wang, founder of 3D Science Valley. Now together, all of them will be speaking more about the topic. Can additive manufacturing rebuild resilience in a disrupted global trade landscape? And of course, Joris will be our facilitator for this session. So everybody, you do have a QR code that's placed on your tables. Feel free to scan the QR code so that you can submit your questions accordingly. And with that, I'll leave you in the good hands of all of them. Let's give all of them a big round of applause.
All right, so guys, welcome. Really glad we get to do this together. I'd like to ask you the first question, what I'm really curious about, and I think is, can we localize manufacturing without additive manufacturing? And is it something we can do for a lot of things or only very few things? Is it only something that, like you were talking about, these 3 or 4 verticals that we dominate? Should we look at things that are just this perfect business case? Or can we use it for kind of like a broad-based duct tape to manufacture all sorts of stuff that isn't working? I'm wondering if you guys have an opinion on that, what you think of that kind of idea. Everyone at once?
If you're looking at me.
Yeah, totally.
Yeah, of course we can localize manufacturing as long as it's a business case. I mean, we all like to talk about 3D printing as changing manufacturing, transforming everything. As long as we don't make money with it, it is not worth it. Right? So as long as you can get it cheaper somewhere else, you're going to get it cheaper somewhere else. So at the point where we combine a good business case with localized manufacturing, I think we have a business case, and that depends on multiple factors, on how difficult it is to get a certain part in polymer or metals around the world. In the past, it has been inherently easy for Western companies to source outside of their home country, to source products predominantly in China, which built up a huge manufacturing workbench there. Just because it's cheaper, and B, nowadays also because it's available and it's fast. We all heard the stories of sourcing people telling us that it takes a tremendous time to just answer to a request for proposal sometimes. So if a procurement officer is reaching out to local companies in the US or in Europe, sometimes takes a couple of days until they get an answer, until they get a quote, right? So I think until we don't fix that problem, it's not worth talking about how additive is changing everything, because it doesn't depend on additive. You can also localize with injection molding. Why not? You can buy an injection molding machine. You can print or produce traditionally your tool, and you can also speed up that process. It's not the technology by itself that changes that. It's politics. It's the ecosystem around it that changes it. But 3D printing certainly enables it and enables company to faster source products, especially when there is a short-term need for it and when there's a certain criticality to the product itself.
Yeah. And do you guys think that, I think it's a good point, and I think also about that there's a lot more friction that in, request for proposal systems, defining parts, pricing, all that kind of stuff. What do you guys think about the likelihood of additive becoming a more prevalent manufacturing technology? Do you guys think that it's going to grow much more, or only is it going to be in like exigent circumstances or when there's like actually a problem?
Right, I think for Singapore, it has always been part of the advanced manufacturing landscape here in Singapore, especially when it comes to technology. So I'm sure most of you know that actually in Singapore, manufacturing is the second highest contributor to our GDP. So I think we've been doing this for more than a decade, and the scaling up of it has been a challenge, as Terry has alluded to earlier. And when we're talking with a lot of our ecosystem players here in Singapore, a lot of that challenges come from really what's the pipeline of the things that I'm going to be producing with additive technology, and who are the partners that they'll be working with, because a lot of, I think Terry also mentioned that more than 50% of our ecosystem players here that's local in Singapore are producing parts as service bureaus as well. So back to your point on whether we can localize manufacturing here in Singapore using additive technology, we are very, very hopeful and very optimistic with that. But I think, well, we echo also Matthias' point on what's the business case here and whether it really provides that competitive edge to manufacturing landscape here in Singapore, because we want to be very technology-centric. We want to be providing our manufacturers who have their manufacturing facilities here in Singapore certain advantage, not cost advantage for sure, because that's not quite relevant for Singapore. So that advantage in terms of really doing something very high-tech, requiring a lot of talent with specialized skills as well. So this is what we will be focusing on, working with our partners here in Singapore in terms of really scaling that adoption and making additive more mainstream in that sense, in hybrid with traditional manufacturing. We are also cognizant with the fact that the traditional manufacturing is going to stay. It's going to be still a huge part of manufacturing landscape here in Singapore.
Okay. Yeah. Esam?
Again, my answer short would be it depends. It depends on the case, business case, and all spillover costs associated with localizations. I would like to give you an example. In Canada, there are opportunities to make legacy parts for the oil and gas industry in Alberta. And in Canada, again, we are producing raw materials, and we are having a lot of resources available. There had been one case that I'm aware of it, that one Canadian company are using Canadian resources, producing very complex components for the oil and gas industry. The entire workflow, end to end, has been localized. For other examples, unfortunately, the story wasn't successful that much because the overhead, specifically in Canada, is extremely high. If we would be able to really do clear life cycle assessment for the business case, for the product, and if the overhead would be reasonable, the potential of having localized manufacturing is here. However, another thing that we need to be very careful when we consider localizations of manufacturing, when additive manufacturing is a part of it, we need to think about integration. We cannot get rid of traditional methods. We need to integrate AI, we need to integrate robotic systems, and we need to integrate traditional manufacturing methods as well. As a matter of fact, we see a lot of activities in automation and robotics over the last few years to see whether we can replace a part of labor workforce to minimize overhead as much as possible.
I think it's an interesting point. Also, it's notable that Canada, of course, produces titanium, one of the largest titanium producers in the world, and oil, which could be used for the. So the fact that you guys can't do it is also, it's like extra damning for other countries, I think. And Kitty, would you like to say something on the subject?
Additive manufacturing, in the end, is going to be mainstream manufacturing technology. In terms of evolution, if you look into how human beings utilize the resource on the Earth, it's always from big waste in the start, and then maybe less weight during the technology revolution, industry 1, and then less weight, less waste. And for additive manufacturing, if you compare with CNC manufacturing, you cut the metal from a block, and a lot of chips flow away with the lubricants. That is not sustainable at all. So eventually, additive manufacturing is going to be the mainstream manufacturing technology. Okay.
Yeah, I think it's a good point. Buy to fly, of course, very important. If the cost of quality is high or the cost of material, then of course it gets extra dimension, this idea of the wasting of chips and stuff. Terry, would you like to say something on this question?
I could, but they said it all. So
Very good. Okay, so another thing is like, well, how about, can we be proactive? Like imagine, we're hearing about additive always that it's a variable, modular additive technology for manufacturing things. Can we, for example, as a manufacturer say, well, I have a number of AM machines, right? And I have a number of parts I qualify. I know they're more expensive than the injection molded parts, but I can create a buffer, if you will, to manufacture if things go south, if things go wrong. Does that make sense? Or is that kind of like a wild goose chase where if you were looking like at a company, like if you're looking at something like Ford or something, it's got to be almost impossible, right? But if we're looking at a much simpler company, like the company that makes Sennheiser or whatever, Shure, who makes these headphones, and the headphones and the microphones and stuff, can we be looking at the chief components that we source from certain countries? Can we create a buffer and be proactive? Or do you think that doesn't really make sense for companies to do this? Anyone think that, yeah?
you mean as a kind of a backup plan?
Yeah,
in
yeah,
case
exactly.
the supply parts are disrupted?
Yeah.
I think for some industries like healthcare, certainly governments with defense, manufacturing, need to have these backup plans in case something very big and serious is disrupted. So yeah, I think that almost goes without saying. We learned a lot in 2020 during the pandemic when we couldn't get things like nasal swabs and face shields and respirators and so forth, and we went to work as a community around the world manufacturing these devices, and it really bailed out the world in some ways.
Okay.
So,
But it's interesting to me to know that, like, you know, a lot of companies dual source or have these plans, and a lot of other companies don't. Like even after the pandemic, we don't see a lot of companies invest in they're kind of in this buffer kind of or proactively planning for a disaster, let's say.
right.
Is that just the nature of how businesses operate or something? Or I don't know.
It's also about the design of the product, right? I mean, you design usually to a certain manufacturing technology, and then if you design an injection molding or a machining or casting part, you cannot, in most cases, it's not so easy to just replace it with additive. I mean, what you mentioned might have a much bigger impact. Actually, it's for me, it's the holy grail of additive to enable companies to combine certain technologies for the same product. We've talked about it with several automotive OEMs a couple of times. If you're able to qualify certain geometries for additive as well as a traditional manufacturing, a high volume manufacturing technology, for example, if you have a casting part that's an aluminum casting, and you can qualify it at the same time for additive as for casting, you would be able to ramp up your whole production much faster because you don't have to wait for any tooling. Then you can do the main production cycle with casting in traditional way, and everything that's beyond that, or that's some special series, or that's after sales, or everything like that, you can do with additive. And that's something that a lot of people see as a holy grail in additive. It depends a lot on qualification and upfront efforts to actually enable the additive to be recognized in terms of material properties, to be similar or even superior. Sometimes it's even a problem if they have superior material properties to printed aluminum parts. So if you manage that, if you develop an application for two different and qualified for two different manufacturing technologies, then you have that backup plan automatically. I think not many companies, only the ones who are visible to big risks, are maybe the ones who need this backup plan. I think from a broader perspective of an actual interesting business case, it's really about ramping up and after sales to combine those two aspects, especially I think automotive is the best example, but there's many other industries who have a similar issue.
Yeah, I think automotive has tens of billions of dollars of parts. I know that, like, other people that care about spare parts, like Miele is looking into this. These companies that have a real concern about, they want to keep their products alive for 20 years. Medical device, these kind of things as well. Anybody else want to say something about this particular question?
I just thought it's also a good time to add to the fact when we're talking about backup plan. This is when I think digital inventory will be really highly relevant. So we in Singapore is also we're trying to encourage digitalization of inventory, and we do realize that there's a lot of gap in terms of transitioning these physical inventory into digital design. And we thought that if we have the digital design on hand, when there's a need and when there's a manufacturing line that's down maybe miles away from where you need it, that's when you can almost immediately activate your backup plan and get a lot of these. We have a healthy amount of service bureaus here in Singapore to qualify them. Or the idea is also to pre-qualify some of these service bureaus so that they can be activated at any point in time for any supply chain disruptions. Yeah.
I think Terry and all other panelists mentioned it very well. I think for high-value components, for defense and for aerospace, potentially having backup plan when additive manufacturing can be a part of it makes sense. I'm not sure about commodity. I'm not sure about this option for SMEs who are not sitting on too much cash. They have to put a lot of cash and capitals to really have 3D printing systems that are being dust collectors. I don't think that many SMEs will go with that path. Obviously, additive manufacturing bureaus would be able to help. How we would be able to connect all these SMEs with AM service bureau that can help them during crisis, that would be kind of, in fact, big questions to answer, because I know there are some sort of fragmented workflow between current SMEs, at least in Canada, and those AM bureaus. More than 60-70% of companies are not that much aware of additive manufacturing features. And I believe training becomes so relevant. If you would be able to really train next generations of engineers, and those engineers penetrate into the SMEs, they would be able to be advocate for additive. I see a big gap. at the moment. Regulations are another part of challenge, at least in North America. Many companies are asking for certifications. As Terry mentioned, 60, 80 years ago, within 3-4 years, people were able to actually fabricate a submarine. But now it takes about 6 or 7 years to really certify additive manufacturing components. Whether company, even for high-valued components that are certified, whether they rely on additive manufacturing to really create replicates of components in crisis when those components are not certified for those industry.
Mm-hmm.
All of them are some of the challenges that industry is facing.
Yeah. There's one question, actually, the audience that kind of dovetails really nicely with this, and that's, given this length of the qualification time period for metal parts, and the person asks, what do we think is needed to proliferate AM for resilience while satisfying interests of major stakeholders for every industry, regulators, technology providers, and users, consumers? What would we need? If we could just magically have a magic wand to make it all go away, easy qualification, I think, is I think the top of my list anyway. I don't know if anyone has things of what we would need to really do to make all of the people happy with the new parts.
Cut unnecessary regulations.
Yeah. Okay. All right. Okay. All right. So guys, another thing is, so imagine we have this buffer thinking, and we're thinking about bufferized manufacturing. There's like this, we know that people are doing containerized manufacturing. The military is doing this. People are doing this in austere environments for oil and gas. Isn't it wonderful? I could put my 3D printers in a container, and then I have tariffs against me in China. I just move the container to Vietnam, and I make there. And it seems like beautiful, right? This idea to containerize manufacturing, move it around. Is it that simple, or could we be doing something that opportunistic with very different, with some product groups or some parts?
Why does it need to be in a container?
Well, because it's easier to manufacture. Everyone always puts it in a container. I don't know. It's like, but also to know what it means. Like literally, kind of like a containerized vision. Like literally, I take a 40-foot shipping container, I take it to a new country, plug it in, ta-da! I'm good to go. Do you guys think it's like is that like ridiculous? You can say it's ridiculous. I mean,
it's happening in defense, right? It's good for battlefield, but not sure about moving one container from country to other country. I'm not sure about that.
Okay. All right. So somebody in the audience also asked if we have 1 or 2 examples how a company's supply chain was broken and rebuilt through additive manufacturing. Now, sadly, I don't know if you guys have some examples of that, because there's not a lot of examples of this, because usually somebody made a really big mistake. The one public example is the Lamborghini for the Gallardo had a mold for a wishing wiper insert for the light. So there was like a wishing wiper on the light. Somebody didn't make that mold correctly. It wasn't in time. They didn't want to delay the launch of the car, so they made SLS parts for the first 500 cars. And that's a bridge manufacturing example we always use because that's the one we're allowed to use. And there are many more, but usually it makes the company look very bad. So I don't know if people happen to have like, and this is just simply like they used, as an intermediate part for the first 500 Gallardos, they used a SLS part, SLS GF, PA11 GF part. So does anybody have any other examples we can share on this?
One of the best examples that I found is the airlines. Singapore Airlines, Emirates, Finnair, Lufthansa, United, and the list goes on and on and on. They are all dealing with the same problem. That is, when they have aircraft for 20, 30 years and parts wear out. Mm-hmm. And these are not critical in the sense they're not structural parts. They're not metal either. They're interior cabin parts, but they wear out or they need to be changed in some way when they're reconfiguring the interior. And yesterday at this company I visited, it's like I had no idea. Well, actually, I did going into because I learned a bit about it before I arrived, but 6 to 12 months to get simple parts. and they can reverse engineer and print these faster and in some cases better. They have the same, if they have to cover them with leather or coatings of that sort, but yeah, and so they are doing that, and that's I think a case where their supply chain is totally broken. They're left with like, what do we do? Mm-hmm. In some cases, they can't get the parts at all. Mm-hmm. The companies that supply them, they only want to deal with new, mm-hmm. and so it's working, and this company wants to scale up and service other organizations, other airlines around the world. I think it's a big opportunity. Mm-hmm.
Anyone else have any examples on this that can share?
I think there's a lot. If you look at the shoe mold, Wallace has mentioned in China, usually we need to cut the surface by CNC machine. It's very challenging. You need to use high-speed metal cutting CNC machine to do that. Now they more shift to use 3D printing to print all the textures in one turn. And if you think about dental industry, usually they also need CNC metal cutting to do the to do the dental parts, and now they just print all of the dental parts like a baking, in one turn. So dramatic changes. A lot of because we don't feel it. Since that is something happen behind the curtain, actually it happen every day.
Mm-hmm. Yeah, bridge manufacturers are much, much bigger and used much further. And I agree with you, Kitty. It's like people don't disclose it, they don't talk about it. So there's a question about AM service providers versus vertically integrated OEMs. Is a dedicated AM service a stopgap until OEMs fully integrate AM into all workflows? I'm guessing here OEM is used as a manufacturer. Let's say it was a car part manufacturer. I guess that's how they mean to say it. So do we think that it's a stopgap, or could you maybe use additive at scale, or may use it for critical parts while not having any additive machines, just only relying on a supplier? Do you guys have any opinion on that kind of idea of like, should you? Is it just a temporary measure, or should you always work with the service bureau, or should everyone integrate additive? I guess is the other question. No. I personally, what I tell customers is always, you never want to do it themselves. Always start with a service. Everybody's too quick to buy machines. They buy machines they don't need and not the right machines for too much money. And it takes much faster to get started with a service. So definitely I would just get started with a service, and later on, I would always rely on a service for a small percentage of your production to have any kind of backup capacity. And also, services have many more materials. You're not going to want to have a scenario where you have an SLS machine with black material in it just standing around doing nothing on your balance sheet. That's just not something I don't think I want. So I would always consider a hybrid model to be the best kind of thing personally. Ersan, do you have something to say on this?
Yeah, I think we see, at least in Canada, some aerospace companies who are getting away from having 3D printers at their site. They're relying on additive manufacturing service bureau. I cannot really disclose the name of those companies. Some of them are really well known, but they work with universities. They develop recipes when that AM service provider is a part of that collaborations. So they move with that recipe development for a few years, design for additive, developing process recipe quality assurance specifically is very important, using machine learning to identify defects in the parts for passing and qualification purposes. But after that, they simply work with that service providers for serial productions. Mm-hmm. And we see this trend more and more. Maybe one of the reasons that some of these OEMs, machine providers, are not really selling too much.
Mm-hmm. Mm-hmm. Yeah, totally. So another thing, we could look at another question as well. Somebody wants to know the difference between a digital and physical inventory. That's a big kind of a big area, I think, for a lot of people to think about and talk about. We're seeing Pelagos is doing that here. A lot of other companies are doing this as well. what does it mean for a company to adopt a digital inventory, and what does it actually mean? Like, do you have to qualify everything? Is it just a scan of something? Is it a part number in SAP? What does it mean for, I don't know, John, you want to say something about this, or?
Right, I want to say that we have a digital design innovation center where you can go right to answer some of these questions that you might have. But I think in a nutshell, it really is having a lot of these stockpiles in your warehouse where you don't know when you're going to need it and where you're going to need it, and then start thinking about, is there any way to then build a digital inventory? But this is probably more for, it can be legacy part, it can be certain parts that are sitting in your warehouse. So then if the part is already existing in a physical form, perhaps that's when you can do a reverse engineering, you can scan and whatnot. But if there are certain parts that are, or certain products that are still in development, then that is when you could even think of design for additive manufacturing, because that's when a lot of that part consolidation could happen, and even part performance improvement as well. So we do realize that it requires really a lot of expertise in this area in order to make that happen. So this is why we're also plugging that gap in terms of doing training for our engineers, and also having a dedicated training program, and also dedicated design innovation center to help plug that gap. Yeah.
Mm-hmm. Yeah. There's another question from the audience member that kind of like hooks up to this. It's actually, it's a bit, I think it's asking a bit much of us. It's asking us if we know a practical legal arrangement for companies using AM to address obsolete parts that the OEMs themselves are not producing, while still protecting the OEM's IP rights. Now, I don't know if we're going to come to the solution to this, because I know I've thought about this a lot, and I haven't been able to come up with it for hours and hours and hours, but I don't know if you guys could just on the dot come up with it. But it's a vexing issue, right? You've got an OEM part that is Exco made it, Exco's out of business. What does that mean? Well, it depends where you are, right? Who's responsible for that part? Maybe they have some IP rights on it or design rights on the part. How can you go around to making it? I know there's certain people, like Worth, for example, is coming up with a framework where they let you use it and they give you a kind of, you get a licensing fee if somebody produces it for you. Something like that. I don't know if anybody has a solution or have thought about this, because I think it's a really vexing thing. Like, am I allowed to make a part that the design doesn't belong to me? And what does that even mean for me if I do, right?
I think a lot depends on whether you're going to sell the part and make a business out of it. If you're making it for yourself, and laws change by region, even by state in the U.S., but by region in the world. So it really does vary. But generally, these companies, these airlines, I go back to it, they're taking parts that Boeing or the seat manufacturers or Airbus, that they are reverse engineering those, and they're not being challenged legally by that. So, but it really does depend on the case.
Yeah. Yeah, I think this is one, like, it's a hell of a solution. I think FieldMade is working on something as well, where they kind of collectivize the rights, and basically it's like an organization, all the big oil companies all working together, and if you go against them, then yeah, it's not going to be great. This is another way of solving the problem. So I don't know if we will come up with a solution for it. If you do have that, that's I think a very important thing. If you can come up with an equitable solution for everyone involved, I think it'd be a really important thing. I think it's also, you could reverse the question and say, how do we incentivize these parts guys to say, hey, I feel good, and then you make this part, give me free money for something I don't have to do. I mean, that's another way of looking at this this kind of thing. So this is another question. It's about kind of like, how can we anchor AM in Singapore with companies choosing to produce nearer to the site of use due to the disrupted global trade landscape? So this is an interesting person. This person is thinking very geopolitically about the situation, saying, well, if everybody starts making everything in Denmark or something close to where everyone is, or in Florida where all the consumers are, what are we going to do? How can we anchor it? Does anybody have any opinion on that kind of thing? How we would do something like that?
In terms of anchoring AM, are we talking about anchoring AM activities, AM production, or are we talking about anchoring that innovation here in Singapore? So for us, we are very keen to have all these additive manufacturing innovation being anchored here in Singapore, using our extensive ecosystem of research institutions here to work together with our companies and advance that innovation that is then going to be perhaps used in various production sites for that particular company. So I think that would be probably a more realistic method for Singapore, because we don't have a lot of land space for a lot of that manufacturing activities to happen here in Singapore. So I would think that yes, it is possible to anchor additive manufacturing here in Singapore, but through anchoring the innovation activities here.
Yeah, that's a good point.
I think Singapore could anchor itself as a innovation driver for additive manufacturing for global, and from culture-wide, that is from technology-wide. From culture-wide, Singapore really has its own advantage. Like what I have watched Li Guangyao, his speech 60 years ago when Malaysia kicked Singapore out, and he said, be warm and be calm. I think that is truly rooted in Singapore. If compared with China, China is also very warm, but maybe we are not so calm. It's a little bit 卷, you know, too much competition, and especially maybe my friend Lida, he has the same feeling. And for Singapore, such kind of culture is really attractive. Keep it going on. And that is the uniqueness of Singapore.
And somebody else wants to know of, well, so there's two questions. One is like, what's holding us back from being a standard? And the other one is like, how can we lower the cost of specifically metal additive manufacturing to be more aligned for conventional manufacturing, but still in a high mix kind of environment. So how can we get that thing? Kitty already mentioned this before, how we can kind of compete with CNC. She thinks very positively that we're going to be there just because of material usage. But is there other stuff that we could be doing to make it even cheaper or cheaper faster maybe?
Yeah, for sure. For very complex parts, like with internal cooling channels and dual alloys, that is some unique advantage for additive manufacturing. If you take what China is busy doing, like for the electronic components, China is doing very thin components. That is not possible for traditional manufacturing to manufacture. The other day, I visited a friend's factory. They do very, very thin wall for titanium parts. It's TC4. It is no way for traditional casting plus CNC to do, because casting-wise, you cannot do such kind of wall. CNC-wise, you have the interface of the tools. That is only where I'm only talking about the shape, right? If you take microstructure into consideration, additive manufacturing is capable to do much more complex microstructures compared with the traditional manufacturing. So it is indeed a technology which is revolution the whole manufacturing concept in terms of the parts performance.
Yeah, I think that's a good point. Yeah.
I think design for additive and consolidations are key here. If you would be able to think differently, if we design the components based on additive criteria, consolidate components together, we can bring down the cost. Taking conventional design, trying to adapt it to metal 3D printer specifically, I don't think it would be flying. On top of that, life cycle assessment is extremely important for companies to really do it upfront to understand whether that printing makes sense or not.
Yeah, I think that's a good point. If you think of something not as a discrete assembly or like lots of different parts together, but something where energy flows through, and you design it from first principles from that, you're going to get a very different device and very, very different optimizations than, yeah, this redesigning parts, which we all know. I think that doesn't really, well, it could work, but from a cost picture point of view, yeah, you're playing to the conventional manufacturing strengths really with a very different technology. Just on the cost thing, I mean, there's other things. We can make machines much faster or cheaper. We're seeing very large machines from SLM, for example. We're seeing very cheap machines from companies like BLT and Forsoon and stuff like this. Also, there's a $40,000 LPBF, metal LPBF printer on the market now, which I'm not sure I would have at my house, but that's a really new price point. So do we think that this is, should we get faster, higher performing machines, cheaper commoditized type machines, or will both happen at the same time, as we see is happening in a lot of industries? What do you guys think? No?
I mean, go ahead. No, go ahead, please.
No, I'm thinking more from the perspective of new technologies and innovation, because that's also when the price point kind of get disrupted a little bit. So we've seen some partners who came by from Fabricate Labs. I think he's also speaking tomorrow or later today. That's really disrupting that cost point, because it's a completely new technology in terms of doing copper printing, 3D printing. And we also have some local institutions who were looking at this technology called the lapis technology. So it's called after our national snack called kue lapis. So it's layer by layer. So they do like a stencil style. And the cost of the material is very low, and it's very accessible as well. And they could do very complex design, from complex design, huge part, to also small parts with internal channels as well, because you don't have that issues with having to remove the powder from those internal channel, and at a very attractive price point as well. So I'll say that the technologies are also disrupting the price point and the cost. So it may come to a point where it no longer would be a question about, actually, is this too costly to use additive manufacturing to produce certain parts? Yeah. So I'm pretty positive about that.
Okay, that's very good. That's very good. And if you guys are looking at this kind of this industry, well, if we're looking at the industry, one of the biggest things I think is Bamboo and their kind of really accessible desktop systems. That's causing a lot of competition. That's causing millions. They may sell maybe 3-4 million printers a year or something, which is an astounding amount. And if they all go for like 300 to 1,000 euros, it would also add up to an astounding amount of. It's a very rough estimate. We don't have a lot of collaboration on that. So these desktop printing companies are really making the market. Are they going to disrupt the other market? Because that's what everybody thinks. They're saying, oh, they're going to disrupt and they're going to go up. Or they're just going to make 3D printing much, much bigger and much more accessible. Or in other words, are we going to have a desktop 3D printing revolution after all? But now much later than everybody expected it to come the first time.
Yeah, having watched this for a long time, yeah, I would, the latter, no. I don't think that we're going to have multiple 3D printers in all of our homes. Okay. I just don't think anytime soon. Now, there are exceptions to that. If you're an engineer, if you're a young person who likes to make stuff, and or you want to get your child, yeah, there are exceptions. And so we'll see that more as makers and people who are creative and want to produce stuff. Because as a kid, I was always making stuff, right? So I would have been a good candidate when I was young. As far as the increasing popularity and proliferation or spread of these 3D printers will do nothing but, I think, good things in terms of helping to introduce the technology to people who otherwise wouldn't be introduced to it. We'll see it in more educational institutions. We'll see them improve to the point where they will compete and already do compete with machines that are 5 or 10 times more expensive. So all of that is, I think, good. Competition is good. That's inevitable. We're already seeing it, and I think we'll see more of that in the future. Does that address your question?
Yeah, totally.
I'm a bit more optimistic when it comes to if everyone has a printer. I think, would you have thought that everyone would have a 2D paper printer years ago? I think if I look at especially the architecture of a Bamboo Labs, if you take it apart, it looks pretty similar to a 2D printer today, because it's designed completely differently with the purpose of a mass-produced, commoditized IT item, IT hardware piece. I think a couple of days ago, they announced the next version that includes a couple of functionalities that enhance the quality, or at least enhance the process control in terms of checking with the camera if parts are still sticking to the base plate, things like that. Things like other companies are way don't have the same maturity yet, although they're industrial level machines. They're just talking about those types of AI control, and they're just implementing it because the technology allows for it. It becomes more and more like almost like a cell phone type of product. I think it's just the beginning, to be honest. If you think about that companies like Zetterfeld, for example, printing shoes today, what stops us of printing our own shoes at home at some point? If we have the platform for it, it's just TPUs. It's nothing, not so many special things around printing shoes. This is just one example, and there are many others. It starts with available data and the availability to design things, but there are things happening also on the software side to simplify design, to simplify use, etc. I'm much more optimistic that this might actually change a lot in terms of printers being really available for $500 and less with the same reliability and quality in the end, and many people accessing 3D printing that haven't been thought about it before. Mm-hmm. And in the end, I think this indirectly impacts the industrial side because it's a generational thing. It's already happening that so many people get into the industry right now. I've seen that in a couple of German companies where people come from university who have worked through their student life with 3D printers in labs and hubs and everywhere. They come to the companies and they realize, why are you guys still injection molding those parts? I wanted to have faster design cycles. Why are you still stopping yourself from innovating faster? Let's do that. Let's print those parts. And this is also generational change that comes with it in the end that will enable this industry to grow further and further.
Can I counter that for just a moment? I agree with what you're saying, but printing our own shoes, there'll be exceptions. We'll be seeing some of that, but we've had $1,500 CNC, 3-axis CNC milling machines available for 25 years. How many people that your friends, relatives, whatever, have one and are using them to build stuff? Almost no one. Here's another example. How many people have sewing machines in their homes? Yeah, we do. And do we make our own clothes? No, we may repair some rip on a clothing, that sort of thing, but why aren't we making our own clothes with these sewing machines? We can buy the feedstock in the form of fabric. We can buy buttons and so forth, but we're not doing it. Now, maybe you could argue that it's not as straightforward, but making shoes, good quality shoes, aren't necessarily straightforward either. I'd rather have a professional that has the know-how to do it well. Maybe you collect the data at your home with an app. And I've actually, I have footwear that were sandals and then insoles that were custom made using an app to capture the data, but it's sent off site and then printed and sent back. Only parts of it were printed. Major parts of it were made conventionally. So that's another reason why. Now I see you're wearing some 3D printed shoes there. I don't know if, did you print those?
Not myself.
Yeah.
I want to deal with the resin.
Yeah. Do they have a bottom on them?
Yeah.
Yeah, but it's transparent. It's good for the temperature around here.
Yeah, okay.
Okay, and Kitty, yeah?
I want to add a little bit. I agree with oral speaking. I agree with Matthias. Because Bamboo Labs, the scaring part of Bamboo Labs is it is the first time for human beings to make a entry-level, consumer-level 3D printer. Actually, for industry level, purpose, it's mass production. It perfectly suits for mass production, and in terms of small quantity, it of course is perfectly suitable. So we need to look into how revolution this technology represent. And that is a totally new era for us. And I'm an optimist that in the next, for the audience here who doesn't have a Bamboo Labs printer, please travel to China. They just opened a retailer shop, like Apple shops, and they are aiming to evoke the creativity for everybody. I think that enable us, a normal consumer, to say no to the lousy products we have been used to get along with. We could be creative with the design, and we could do it ourselves.
Okay, thank you. So if we look at these making ourselves things, if the idea of this question was that if we see this proliferation of these inexpensive printers with inexpensive parts, if we only have 3 in Singapore, it won't help. It won't change anything. But if every home has one, or if we have 10,000 of them or 100,000 of them, then of course it would make a real difference in the resilience architecture of this country. Again, in the United States, 100,000 wouldn't be enough, right? So do we think that the desktop printer is the path to this resilience? Or is it more like industrial processes, industrial machines? Because we've been discussing 2 things, right? They're the same industry. We're talking about a €1,000 machine, a $1,000 machine that competes with like a $5 million one, or they have nothing to do with themselves, right? If I'm SpaceX, I'm not gonna, well, I do make some parts on bamboo, but I won't make a lot of end-use parts of the rocket on the bamboo. But are we seeing the co-evolution of these things, or is this market very split? Or if we look at entry-level systems or resilience, should we be focusing on the low-cost, accessible technologies, or should we be focusing on these exquisite, more expensive, large LPBF systems and things like that? What do you guys think?
I think resilience, this resilience topic, I think, is always related to somewhat to industries that have a big pain in long lead time. Mm-hmm. If things take 6 months to be delivered, and I think you don't need the Bamboo Labs to do that. You can do it also with every other type of printer, as long as you have the fast lead time. Mm-hmm. I think that those desktop printers are rather the enablers of more and more people to adopt 3D printing. It's increasing the adoption, and it's going to vertically integrate into the adoption rate of industrial users as well as consumer adopters. But in the end, for most of those resilience topics, it's about parts that have a certain requirement, certain demand that requires a production level printer, some kind of certification or everything else around it. So I would say it's 2 different worlds, but there's an overlap somewhere in between.
Yeah. Ashton, I have a particular question for you. It's like somebody wanted to know, well, what rules and laws and you would like to scrap to really accelerate the additive manufacturing adoption?
Should I mention it within the context of Canada?
If you want, just to give us an idea. I think
there are a lot of regulations about safety that are not really helpful, to be honest with you.
Yeah.
So you want to just go with, even if we purchase a machine from the US, we have to go with CSA approval. Mm-hmm. The US machine, a machine made in the USA, if we ship it to Canada, we need to get another certifications. That may actually take about 6 months.
Yeah.
This is one of them. I would like to cut it off.
Yeah. Okay. That's a very good point. And so just generally, I think I mentioned this point earlier, like we were talking about this, it's okay to have the machines and the technology. We've been talking like kind of a very technological solution. But, I could give 2 companies all the training and all the things, the machines they want, and one could be resilient and the other one couldn't. And the same with countries, other organizations. Should we be doing more about a culture of resilience? I know as an additive manufacturing industry, we kind of embrace failure, and we fail a lot, and we kind of like failing a lot, because that's kind of what our technology does. Is that maybe the most valuable lesson, or can we do other cultural things to make certain organizations adopt it? Because I know, to me, it comes back to that point from Ukraine where a soldier can order a part. Just order a sketch and say, I want this. Whereas other militaries are not copying that. They're doing everything except for that, because they're a hierarchical organization. It doesn't work like that. There's no structure like that. So I'm just wondering, what kind of other things do we have to do to kind of make organizations or people more resilient? Is that something that people feel strongly about or just have an idea about?
My feeling is that we need to start educating our undergraduate students and also high school students. We see some major gap for critical aspects of additive manufacturing, specifically designed for additive manufacturing, which is not really taught at universities level. I think we need to actually have more certification programs embedded within undergraduate curriculum. This is something which is missing from many, many universities. Even in Canada, if you take a look at, we have a national network called HIAM. Maybe 4 or 5 universities are trying to include some of those additive manufacturing concepts into the curriculum to really train our engineers who would be advocate for additive manufacturing when they get to the market. So I think this is training is a big part of shortfall at the moment.
Yeah.
I think in terms of organization resilience, there is a new era emerging. Usually people, human beings do knowing the world by trial, based on trial. We do a lot of experiment. I think it's a new era driven by digital twin plus AI. This could provide us more accurate prediction. So if things are predictable, human beings are on a more resilient side.
Okay. So, does anybody have any closing thoughts? Any ideas where you're like, no, I really wanted this. You didn't get to me yours. I really wanted to say this one thing I feel about this topic, or anything you want to get off your chest while you're still up here, guys? Because I think it was an interesting discussion. I think it was a good discussion about this topic. I think it's one of these things where we're stuck in the middle of it. We're in the eye of the storm, kind of. So we don't know if things are going to get a lot better and if we all overreacted, or if this is like the new normal, let's say. So I think it's a really exciting time to be talking about resilience in a place where additive can really play a role, and where additive can really kind of maybe help really change the future of organizations by making them more able to overcome what the world throws at us. It's really funny. I was once interviewing Scott Crump, who invented material extrusion, or FDM, as he gets to call it, and no one else. And I asked him, like, so what is your wisdom for people, like, to succeed in life and all this kind of. And I was expecting this whole story, so I got like my pen and I was like, I'm going to tell a story. He's going to tell a story. He's like, you have to get up one more time, then you fall down. And that was it. That was his whole entire philosophy. That was it. There was no more. And so maybe it's as easy as that. Maybe we just have to learn to accept this adversity and to overcome it. But anyway, thank you guys so much for doing this today, and thank you for being here with me, and thank you.
Thank you so much. Could we have all of you just come in front for a group photo, please? Just in front of the coffee tables. Thank you very much, everybody. So with that, we will be adjourning for lunch. We'll need your help to be back here around 1 o'clock. Thank you very much. See you later.